Okay, so in this journal here, we're going to start with the bell work being something you've seen in your packet, your homework packet. So these two problems, if you're having trouble with your homework packet on page 1, these two problems might help you out. So what it's asking you to do is take F and subtract it. This minus sign here means subtract. So F minus G. So if I've had to set up this problem, I need to start by writing my F equation. So F here is that 2x squared plus 5. So I'm going to grab this equation, drop it down. I like to put some parentheses around it so I know that that's my F function. Then I have to subtract it with G. So G here is the equation in pink, so that's going to be x minus 3. So basically I took the G function, wrote it down, put its own parentheses. So the reason why I use parentheses is so that I can remember to distribute the negative sign to both terms. So if you forget parentheses, you might forget to distribute. So I'm going to bring down the first term just the way it is because there's nothing in front. So I get to bring down the 2x squared plus 5. And then I have to distribute the negative, so that's negative x plus 3. And then from there, I just combine like terms. Like, it looks like I have a constant here. Ooh, that's kind of thick. Let me make that thinner. There we go. I have a positive 5 and a positive 3, so if I combine them, I get 8. So I'm going to bring down the 2x squared, the minus x, and then if I add 5 and 3, I get 8. And so looking at these are all different terms because they're all different exponents, so I can't add anymore. So this is my final answer. All right, so this next one here, you can see it's F times G. So this small dot here implies multiplication, so I'm going to set up my equation where I write F first. So again, I'm going to put them in parentheses. And I'm going to multiply this with G. So G again is x minus 3. And so when I multiply, this type of problem is a foiling problem or distribution problem. So I'm going to multiply 2x squared with x to the first power to give me 2x to the third power. Remember, when we multiply, we add the exponents. Then I need to multiply this to the negative 3. So negative 3 times 2 is negative 6x squared. And then I need to multiply the 5 into the parentheses, so that's positive 5x. And 5 times negative 3 is negative 15. So looking at this, notice how each term is a different power, an exponent. So in this case, this is the final answer because I really can't do much more simplifying here. There's nothing I can combine. And last but not least, I have this problem here, which is F negative 1. So this negative 1 is not implying that I'm multiplying negative 1 to F. This is actually saying I'm plugging in negative 1 into F. So do you remember back long ago we learned F of x, and basically x here is something that you plug in to the function. So it's an input, and then when you work it out you get an output. So in this case, your input or your x is negative 1, and so you're plugging negative 1 into the f function. So wherever you see an x, you're going to plug in a negative 1. So if I were to work this out, this would be 2 negative 1 squared plus 5. So all I did was take negative 1, plug it in for x, and now I'm going to work it out. So order for operation says that I have to do parentheses first. So there's nothing inside the parentheses to simplify, so it's still just negative 1. Exponents are next, so negative 1 squared is like negative 1 times negative 1, which is positive 1. Multiplication is next, so 2 times 1 is 2. If I add that with 5, I get 7. So it looks like my final answer here is 7 when f is negative 1. So when I plug in negative 1, my output here is 7. All right, so in today's bell work, I wanted to show problem number 3 because that is kind of the theme of our lesson for today. If I were to input something, what is my output? Although sometimes it's not numbers that we're inputting, it is functions. We can input functions into another function, and you'll see that today. So we're going to talk about something called composition of function notation. And so what I like to think of functions composition is kind of like a peanut M&M. So if you ever had a peanut M&M, you have to start with the peanut, right? Because you can't just make, so there's like 3 layers of a peanut M&M. There's the peanut, the chocolate, the candy shell. So generally, we don't start with the candy shell and then try to insert the peanut in, because that's impossible, right? Like, you've already made the shell, you can't put the peanut in unless you were to glue it back together later. So it's much easier if you start out with the peanut and then coat it with some chocolate and then add the candy shell. So the reason why I'm saying this is because math works the same way. When you see a function like this, so I want you to ignore this side for a moment. Just look at this side. So notice how this is f on the outside, g next, and then x is in the middle. In mathematics, you actually have to start with the inside first. So you would have the peanut, coat it with chocolate, then a candy shell. Well, in this case, you have to start with x first. So x is like your peanut. It's the core of this function here. So x is like the peanut, or basically the number. So in this case, after that is your chocolate, which in this case, our g of x is our symbolism for the chocolate part, but it's also called our inner function. So after the x, you have your inner function. And then on the outer part of this function, you can see that f is our outer function. So outer function is the function that's on the very outside of the notation. So in this case, the shell here represents our outer function. So basically, composition functions, you'll see them as this notation. Looks like fog or golf, but that's not actually how you say these. This open circle right here, when you see an open circle, it's actually just stated as of. Okay, so basically when you want to pronounce this, it says f of g, which is essentially saying that you're going to write f first and then plug in g into f. So g is your inner function because you can see it's being plugged into f. Whereas this one is g of f, and you can see that g is the outside function and f is being plugged into g. So in the next slide here, I'll show you how do you use this type of notation to simplify some equations. So in example 1 here, you will notice that I give you f. Let me highlight that as green, and then g. And you have to figure out what is f of g. So when we read f of g, just like how you read in plain English, you read from left to right, the furthest thing to the left is always your outer function. So I know when I see f of g that f is going to be the furthest function out. It's my outer function. Inside, if I keep reading, g is next, so g is inside of f. And then x is in the inner core, so the very middle. So looking at this here, all I've done is translated f of g into this parenthesis notation, which is much easier for me to solve. So what we're going to always do, just like how you make an M&M, you always want to start with your inside here. Let me fix that. There we go. So you always want to start with the very inside of your function. So in this case, g of x. So ask yourself, okay, what the heck does g of x represent? So looking at these two functions here, g represents negative 3x plus 7. So instead of g of x, I'm going to replace it with negative 3 plus 7. So here's my f on the outside, and inside, I'm going to replace g with what it actually is. And then notice when I do that, I no longer have g's. I just have an f now. So my goal is to try to get rid of all of the f and the g until I'm just left with like x's and numbers. So in this case, this is saying that I need to plug in f, negative 3x plus 7, into f. So I have to plug this entire thing into the f function. Well, here's f, the function, and f is 2 times x. So in this case, I'm going to write this as 2, but wherever I see an x, I have to plug in negative 3x plus 7. So here's my x. I'm going to replace it with what I'm plugging in. So that's going to be negative 3x plus 7. So instead of this x here, I'm going to replace it with what I'm plugging in. And then I'm just going to simplify by distributing the 2. So now this is just normal math. I'm just going to work it out. So that's 2 times negative 3, which is negative 6x. 2 times 7 gives me 14. And then this here is my final answer. Now let me just pause here for a moment, because one of the biggest questions that people ask me is like, wait, Ms. Shang, why didn't you put that x next to it? Here's the reason why. If you think back to the bell work, if you have a problem that's asking you what is f of negative 1, right? If you saw that you had to figure out what is f of negative 1, you would take this negative 1 and plug it in where x is. So in other words, you would write out this problem as 2 times negative 1 and then get negative 2. So essentially what you're doing is whatever this x value is, you remove the x and plug in what it's supposed to be. You would never write this as 2x, sorry, that's a weird x, 2x, and then multiply it by negative 1, right? Because you know that this is a number that you actually have to plug in to x, not right besides x. So notice how when I plugged negative 3x plus 7 into the f function, I took this entire function, that x right there, removed it, and then replaced it with what I'm plugging in. So that's what you're doing there. All right, let's try f of g. So in this scenario, this g is my outer, and f here is my inner function. So I need to always start from my inner function, which is f. And so f here is actually 2x. So instead of writing f of x, I can write this as g 2x inside. So I've replaced f of x with 2x. And now I have to ask myself, okay, what's g plugged in 2x? So I go to g. Wherever I see an x, I have to plug in 2x. So notice how in this case, here is my x. Oops, sorry, that's a little thick. There we go. So there's my x. So I have to write this as negative 3, but instead of writing that x, I'm going to plug in 2x, and then I'm going to bring down that plus 7 besides it, and then work this out. So negative 3 times 2x gives me negative 6x plus 7. And I can't combine anymore, so this is my final answer. And that's it. So I want to do one more example with you guys in the journal, and then we'll hit the homework packet. So in this problem here, you can see that you have an F, a G, and an H. And so I'm going to, like again, color code them so that way you guys know which function I'm referring to. I'll make this one blue. So looking at these problems here, you'll start to notice that this time around, this here is not an x, it's a number. And so when I get to my final answer, it should just be a number. And so let's see what happens. I'm going to set up this problem very similarly to how I set it up last time. So I'm going to start with my outer function, which is g. I'm going to plug in my f function next. And then instead of an x that usually goes here, it's going to be a 3. So I'm going to be plugging in 3. And so you'll start to notice when you solve out this problem, again, you have to start with the inner function. So in this case, this inner function here is f of 3. Well, let me just write this to the side for a moment. I need to figure out what is f of 3. If I solve this problem here, this becomes relatively simple for me because in this case, it's just saying if I plug in 3 into f, so if I go to this function, I plug in 3 in for the x, 3 plus 2 is what value? So 3 plus 2, well, 3 plus 2 is 5. So that means that my answer for just f of 3 is 5. So instead of f of 3 here, I can just write a 5 in replace of that. So this is going to be g5. And then from here, I need to ask myself, what is g of 5? Well, first you have to go to g, and in this case, you have to plug in 5 wherever you see an x now. So there's an x right here, so I have to plug this 5 in for that x, and then work it out. So negative 4 times 5 plus 3. If I work this out, I get negative 20 plus 3, which is equal to negative 20 plus 3 is negative 17. So it looks like negative 17 is my final answer. All right, this one here has an h of f. So in this one, h is my furthest function, or my outer function. F is my inner function. And then negative 5 is my inner core. So in this case, negative 5 goes in the very middle. So again, you want to start with your first function that's on the inside. So it's using f negative 5 inside. So we have to figure out what is f of negative 5. Let me work that out on the side here. So if I plug negative 5 in for f, that'd be plugging negative 5 here and adding 2. So if I wrote that out, negative 5 plus 2 gives me negative 3. And so that there is my actual value. So instead of writing a f negative 5, I can just replace that with a negative 3 because I already found the value. So h, plug in negative 3. So now I have to ask myself, what is h of negative 3? Well, I have to go to h now. Here's h. But h this time has 2 x's that I need to plug in. So I have to plug this negative 3 into both x values. So this is what it's going to look like. Let me do that in black. So that's going to be x squared, or negative 3 squared, minus 2 times negative 3 plus 1. So wherever I saw that x, I had to plug in negative 3 in for those x. And then I'll just work it out. An order of operations says I need to do parentheses first, then exponent. So negative 3 squared is like negative 3 times negative 3, which is positive 9. Negative 2 times negative 3 gives me a positive 6 plus 1. If I add this all together, 9 plus 6 plus 1 gives me 16. So it looks like h of f, plug in negative 5, gives me the value of 16. And that's it for the journal. In the next slide here, I'm going to show you how you can work out some of the homework problems. I'm going to knock out 3 homework problems here, so feel free to follow along. All right, so in this homework problem here, this is on page 2 of the packet. These are the first 2 function. You have your f function and your g function. I'm just going to color code this. Let me make this green and this pink. And so you can see down here below, it wants us to figure out what is f of g. So let's just go ahead and set that up. So f of g would be f being the outer function and g being the inner function. So if I were to set it up this way in parentheses form, I can see that I'm plugging in g, which is the function that is x squared plus 1. So instead of g, I can just plug in x squared plus 1. So I'm just going to bring down f, and then inside I'm going to plug in g, which is x squared plus 1. And now it's saying to plug in this here into my f. So there's the f function, it's x plus 3. So wherever I see an x here, I have to plug in all of this. So this is going to be x, which is x squared plus 1. So instead of writing this x, I'm going to replace it with what I'm plugging in. So that's going to be x squared plus 1. But there's also still a plus 6, so I need to put that besides it. And then from here, I can see that I really just have an x squared plus 1 plus 6. So it looks like these 2 are like terms. That's a plus 1, that's a plus 6. So if I add that together, I get x squared plus 7. And it looks like I can't combine any further, so this is my final answer. So it's x squared plus 7 for the first equation. For this equation, it's saying f of g. So if I were to work that out, let me just set that up first. Oh, how about I do it down here? So g is my outer function, and f is my inner function. So looking at this here, I need to plug in my f. My f is x plus 6. So instead of writing f of x, I need to write in x plus 6. And then I'm plugging this function into g here. So when I plug that in, that's going to replace that x as an x plus 6. So what that's going to look like is x plus 6. But notice how this x is squared. So this whole thing will be squared. So looking at this here, this is where it gets a little bit tricky and where people can easily mess up on. So usually when people see this problem, they go ahead and distribute the exponent, but you don't do that. Anytime you have like an x squared and you have two terms, you want to write it as two factors. So I'm going to write it as x plus 6, x plus 6. So I want to write it as two factors so that way I can go ahead and distribute and make sure I'm not losing any terms here. So I'm going to do 1 times 1x times 1x gives me x squared. X times 6 gives me a positive 6x. 6 times x gives me a 6x. And 6 times 6 gives me 36. And I'm going to drop down the 1. So when I add like terms, these two combine. And then these two combine. So that's going to give me x squared plus 12x plus 36 plus 1 gives me 37. So it looks like this is my final answer. X squared plus 12x plus 37. Alright, so I'm going to pick out two problems from the bottom part of this page. So this is still page 2. I'm going to do problems 4 because I know that one's pretty hard, and I'll do problem 6. I'll leave the other two for you guys. So for problem 4 here, I have 3 functions to handle, h, f, and g. So if you see a problem like this, you want to start with your translating it. So notice how this, if I were to translate it, this is h is my furthest function out since that's on the furthest left. Then it's f, then it's g, and then on the inside I have a -1. So when I translate it, oh, I see that the inner core is just asking me what is g of -1. So I'm going to make g pink, f green, and then h blue. So if I look at this, I just need to replace g of -1 with what its actual value is. So let me do it here on the side. So here's g of -1. If I plug -1 in for g, that's going to be -3 times -1 minus 7. So if I work this out, -3 times -1 is positive 3 minus 7 gives me -4. So in this case, this is f -4. And then h is on the outer. So all I've done is replace this g of -1 with -4 because I calculated that, as you can see here. So I got the -4. Now I have to figure out what is f of -4. So I'm going to do that here on the side. So if I plug in -4 into this function, that's -4 plus 1. So -4 plus 1 gives me a -3. And so now I get to replace this f -4 with a -3. So I'm going to bring down the h, but now I'm plugging in a -3 in here. So now the question is, okay, what is h of -3? All that is plugging in -3 into the h function. So I'm going to plug -3 into that x and that x. So let me work this out. So that would be, I'll write an equal sign. Be -3 squared minus 4 times -3 plus 2. So if I work this out, I've got to take care of my exponent first. So -3 squared is 9. -4 times -3 gives me positive 12 plus 2. So if I add all these numbers together, 9 plus 12 is 21, plus 2 is 23. So my final answer for this problem is 23. All right, so that one can be a little bit hefty, but you're basically going from the inner and then outer until you get to the furthest function out, which is h. Now for this last one here, a lot of people ask me what's the difference between brackets and parentheses. In this case, there's no difference. So if you have hg of 5, this one's using brackets, but it's just saying that, you know, g is enclosed inside of h here. Oops, sorry. So looking at this, we're going to start with the inner, which is the g of G5. So if I were to plug in G5, or plug in 5 into G, let me work that out on the side. So if I plug in, let me do that pink. If I would plug in 5 into G, that would be negative 3 times 5 minus 7. So negative 3 times 5 is negative 15. Minus 7 is negative 22. So here's my G when I plug in 5. So what's going to happen is that I'm going to now have h left over, and instead of this G5, I'm going to have negative 22. So from here, I'm plugging in a negative 22 into h. So here's h. H has two x values, so I'm going to plug in negative 22 here and negative 22 here. And I'm going to definitely use parentheses here just because I see an exponent too. So if I take negative 22 and square it, let's see, what's negative 22 times negative 22? So I think it's 484. And then negative 4 times negative 22 gives me positive 88. And then I'm going to bring down the 2. So if I add this all together, 484 plus 88 plus 2, that's going to give me 574. And then this here would be my final answer because I finally get down to a number. So hopefully this helps you out with your homework problems and being able to tackle them. By the way, just as a quick tip, I usually would write this here to the side, but it would cut off the writing. But yeah, usually I would write this more on the right side. I just didn't have enough room. Okay, so that's it for this video. See you later.